Chemical process safety is a critical part of battery recycling laboratory work. Safety is not limited to personal protective equipment, it begins at the experiment design stage. The reagents, addition order, possible heat release, ventilation needs, and waste streams must all be considered in advance. In battery recycling, hydrometallurgical operations clearly show why chemical process safety must be planned before the experiment begins. Chemical operations in battery recycling are often multi-step and high-risk processes. During leaching, acids, oxidants, metal-bearing solids, and temperature changes may act together. For this reason, process safety is not only about handling hazardous chemicals. It is about understanding how hazards interact within the process. Students must know not only the reagent names, but also how these reagents behave during the operation. A key principle in chemical process safety is that PPE is not the first line of defense, it is the last. In corrosive or volatile operations, the priority is to prevent vapors and aerosols from reaching the operator. This requires engineering controls such as fume hoods, local exhaust, secondary containment, and controlled work organization. Gloves and goggles protect the person, but ventilation makes the process itself safer. A common mistake in chemical process safety is judging reagents as safe individually, without considering how they behave together. Many incidents result from unexpected interactions between two or more components. In battery recycling laboratories, metal-loaded acidic solutions, oxidizers, and neutralization steps require special attention. The same principle applies to waste management. Mixing the wrong waste streams in one container can be more dangerous than the experiment itself. Heat of reaction is a central concept in chemical process safety. Temperature is not only a value to be measured, it actively affects how the process behaves. In leaching operations, acid addition, oxidizer addition, or rapid solid feeding can cause local overheating. This affects both efficiency and safety. Students must understand that the difference between a reaction occurring and a reaction staying under control often depends on temperature management. A fundamental habit in chemical process safety is the controlled additions approach. Reagents must be added in a planned order and at a controlled rate. This reduces the risk of local overheating, foaming, gas evolution, and splashing. In systems involving oxidizers such as hydrogen peroxide, the addition rate and order are direct safety parameters. The key message is clear: fast work is not always efficient work, it can be more hazardous work. In general, hydrometallurgy is often taught as a metal recovery method. However, in safe laboratory teaching, students must learn how the entire process is managed within a safety framework. Reagent selection, ventilation, addition order, temperature monitoring, filtration setup, and waste segregation are not separate steps. They are parts of one safety chain. A successful experiment is not only one that produces a precipitate, but one that is completed without loss of control. Chemical process safety is a central part of safe laboratory practice. A safe chemical